Hello everyone, welcome to our class. My name is Kuo-Chuen Lee. In today's sections, we will talk about DHCP server. Most Microsoft Windows networks should be configured to use dynamic host configuration protocol, DHCP. DHCP simplifies administrations and makes it easier for users to get their computers on the organization's network. DHCP is a protocol that allows client computers to start up and automatically receive an Internet Protocol address and other related transmission control protocols, Internet Protocol settings, such as the subnet mask, default gateways, domain name systems, server addresses. And Microsoft recommends that a single DHCP server service no more than 10,000 clients. And you define a set of IP addresses that can be assigned to clients using a scope. A scope is a pool of IPv4 or IPv6 addresses and related configurations options. The IP addresses set in a scope are contiguous and are associated with a specific subnet mask or network prefix length. To define a subnet of IP addresses within a scope, they should not be used, and you can specify an exclusions. An exclusions defines a range of IP addresses that you can exclude so that it isn't assigned to client computers. And IPv4 auto configurations works like this. First, the client computer selects an IP address from the Microsoft reserved Class B subnet 169.254.0.0 and uses the subnet mask 255.255.0.0. Before using the IPv4 address, the client performs an address resolution protocol ARP test to make sure that no other client is using this IPv4 address. And second, if the IPv4 address is in use, the client repeats step 1 testing up to 10 IPv4 addresses before reporting value. When the client is disconnected from the network, the ARP test always succeeds. As a result, the client uses the first IPv4 address it selects. Third, if the IPv4 address is available, the client configures the NIC with this address. The client then attempts to contact a DHCP server, sending out a broadcast every 5 minutes to the network. When the client successfully contacts a server, the client obtains a list and reconfigures the network interface. And DHCP is inherently insecure. Anyone with access to the network can perform malicious actions that could cause problems for other clients trying to obtain IP addresses. A user could take the following actions. First, initiate a denial of service, DOS, attack by requesting all available IP addresses or by using large numbers of IP addresses, either of which could make it impossible for other users to obtain IP addresses. And initiate an attack on DNS by performing a large number of dynamic updates through DHCP, or use the information provided by DHCP to set up large services on the network, such as using a non-Microsoft DHCP servers to provide incorrect IP address information. And planning a new DHCP implementations or revamping your existing DHCP implementations requires a good understanding of how DHCP works. And you need to know the following informations. First, how DHCP messages are sent and received. Second, how DHCP relay agents are used. Third, how multiple servers should be configured. When a DHCP client is started, it uses network broadcast to obtain or renew a list from a DHCP server. These broadcasts are used in the form of DHCP messages. A client obtains its initial list as shown in figures. The client broadcasts a DHCP discover message. All DHCP servers on the network respond to the broadcast with a DHCP offer message, which offers the client an IP list. The client accepts the first offers received by sending a DHCP request message back to the server. The server accepts the request by sending the client a DHCP acknowledgement message. DHCP clients must renew their lists periodically, either at which restarts or when 50% of the list time has passed. If the renewal process failed, the client tries to renew the list again when 87.5% of the list time has passed. Renewing the list involves the client sending the DHCP server a DHCP request, and the server accepting the request by sending a DHCP acknowledgement. This streamlined communication process is shown in figures. And although you can configure the DHCP server service for failover a cluster, much simpler and less expensive fault tolerance implementations are available. And these implementations work with large networks as well as small and medium networks. The implementations include the following: 50-50 failover approach. You use the two DHCP servers to make an equal amount of IP addresses available to clients for leasing. The first server gets the first half of the scope's IP address range and excludes the second half. And the second server gets the second half of the scope's IP address ranges and excludes the first half. 80-20 failover approach. You use the two DHCP servers to make a disproportionate amount of IP addresses available to clients for listings. Here you have a primary DHCP server that is configured with 80% of the available IP addresses, and a backup DHCP server that is configured with 20% of the available IP addresses. Third, 100-100 failover approach. You make twice as many IP addresses available as are needed. Thus, if you must provide DHCP services for 200 clients, you make at least 400 IP addresses available to those clients. With workgroups, the steps for setting up DHCP services look like this. First, installing the DHCP server service. And second, configuring the DHCP server with the appropriate scopes, exclusions, reservations, and options. Third, activating the DHCP server scopes. And you install the DHCP server service as a server role. To install the DHCP server service using the Add Roles wizard. Follow these steps. First, DHCP servers should be assigned a static IPv4 and IPv6 address on each subnet they will service and to which they are connected. Ensure that the server has static IPv4 and IPv6 addresses. Second, in Server Manager, select the Roles node in the left pane and then click Add Roles. This starts the Add Roles wizard. If the wizard displays the Before You Begin page, read the welcome message and then click Next. Third, on the Select Server Roles page, select DHCP server and then click Next twice. Fourth, on the Select Network Binding page, you will see a list of network connections that have the static IPv4 address. As necessary, select the network connections that the server will use for servicing DHCP clients and then click Next. Fifth, on the Specify IPv4 DNS server setting page, enter the default DNS settings that the servers will give to DHCP clients for automatic DNS configuration. And six, in the parent domain text box, enter the DNS name of the parent domain. In the preferred DNS server IPv4 address, an alternate DNS server IPv4 address text box. Enter the IPv4 address of the preferred and alternate DNS servers, respectively. Click each validate button in turn to ensure you enter the right DNS address. Seventh, on the Add or Edit Scopes page, you can use the options provided to create the initial scopes for the DHCP server. If you want to create a scope for the DHCP server, click Add. Otherwise, click Next and create the necessary DHCP scopes later. And eighth, click Install. The wizard installs DHCP and begins configuring the server. After you install a DHCP server service, the next thing you must do is to create the scopes that will provide a range of IP addresses and TCP/IP options for clients. With IPv4, the DHCP server service supports three types of scopes. First, normal scope. A normal scope is used to assign IPv4 addresses pools for class A, B, and C networks. Normal scopes has an IP address range assignment that includes the subnet mask and can also have exclusions and reservations as well as TCP/IP options that are specific to the scope. And second, multicast scope. A multicast scope is used to assign IP address pools for IPv4 class D networks. Multicast scopes are created in the same ways as normal scopes, except that they do not have an associated subnet mask, reservations, or related TCP/IP options. Third, superscope. A superscope is a container for IPv4 scopes. If you configure multiple scopes on a server and want to be able to activate or deactivate them as a unit or view the usage statistics for all the scopes at once, and you can use a superscope to do this. In the DHCP consoles, you can create a normal scope for IPv4 addresses by expanding the nodes for the servers you want to work with and selecting and then right-clicking IPv4 phones from the shortcut menu. Select New Scope. In the New Scope wizard, click Next to display the scope name page as shown in figures. Type a descriptive names for the scope and the descriptions that will be used as a comment. And click Next to display the IP address range page as shown in figures. Enter the start and end IP addresses to use for the scope in the start IP address and IP address boxes. Be sure to specify the first and last usable IP address only, which means you shouldn't include the .0 and .255 addresses. When you enter an IP address range, the bit length and the subnet mask are filled in automatically for you. Change the default values if you use subnets. In the DHCP consoles, you can define the exclusion range from right-clicking address pools within the scope you want to work with and choosing New Exclusion Range. In the Add Exclusion dialog box, enter a start address and an end address for the exclusion range, as shown in figures. And then click Add. And keep in mind that the range excluded must be a subnet of the scope range and must not currently be in use by DHCP clients. And reservations provides a way to assign a permanent list on an IPv4 address to a client. And in this way, the client has a fixed IP address, but you retain flexibilities in that you could change the IPv4 address at any time if necessary through DHCP, and rather than having to do so on the client. In the DHCP consoles, Any existing reservations for scope can be displayed by expanding the scope and selecting reservations. As shown in figure, existing reservations are shown according to the reservation name and the IP address reserved. And scopes are available only when they are activated. If you want to make a scope available to clients, you must right-click it on the DHCP console and then select Activate. Activating a scope won't make clients switch to that scope. If you want to force clients to switch to a different scope or to use a different DHCP server, and you can terminate the client leases in the DHCP console and then deactivate the scope the clients are currently using. Now, in the ideal configurations, you will have multiple DHCP servers on each subnet. However, because this isn't always possible, and you can configure your routers to forward DHCP broadcasts or configure as a computers on the network to act as a relay agent. Any computer running Windows Server 2008 can act as a relay agent. Doing so requires that routing and remote access be configured and enabled on the computer first. And then you can configure the computer as a relay agent using the routing and remote access console. In Windows Server 2008, routing and remote access services are installed as a role service for the network policies and access service roles. On a server with no other policies and access role services configured, you can install this role service by completing the following steps. First, in Server Manager, select the Roles node in the left pane, and then click Add Roles. This starts the Add Roles wizard. If the wizard displays the Before You Begins page, read the welcome message and then click Next. Second, on the Select Server Roles page, select Network Policy and Access Services and then click Next twice. Third, as shown in figures, select the Routing and Remote Access Services role service to install it. To enable RAS, you must install Remote Access Service and Routing. Click Next. Fourth, follow the prompts to complete other wizard pages as necessary. On the Confirm Installation Services page, click Install. The wizard installs the selected role services. And you can configure DHCP related agents for IPv4. To configure related agents for IPv4, follow these steps. First, in the Routing and Remote Access console, expand the node for the computers you just configured, and then expand IPv4. Second, right-click the General node and then choose New Routing Protocol. Third, in the New Routing Protocol dialog box, select DHCP Relay Agents, and then click OK. This adds an entry under IPv4 labeled DHCP Relay Agents. Fourth, in the Routing and Remote Access console, and right-click the DHCP Relay Agent entries, and choose New Interface. Fifth, the new interface for DHCP Relay Agent dialog box is displayed, as shown in figures, showing the currently configured network interfaces on the computers. Select the network interface that is connected to the same network as the DHCP clients whose DHCP broadcasts need forwarding, and then click OK.